Hello. Until now, if you have been following this series, you've seen ways to actually obtain data from one database table, doing things like selecting specific columns, changing their name, limiting which rows you are looking at, carrying out calculations, grouping the data, but always remaining within one pre-recorded data table. But relational databases allow far more. Their greatest quality is that you can have several interrelated tables of data, like for example the personal details of a customer, and then separately details about which account those customers hold. We're going to look at how you can use those multiple tables, bringing together the data from several of them inside a single result. We want to select data from more than one table and then compare it together. So with this idea of working with multiple tables, here is a thought. We could select two different columns of data that come from the two tables. Name is from the cost table and account number from the customer account table, and just put them side by side. But the result we're getting is not exactly what you might have expected. You see, it would be good to see our best together with, now which one is our best? Reference number B127, B127 is here together with 5418. But look at the results. Our best is over here with 1, 2, and then they are again with another account, and again, and again. So what's happening? What we got is what we call a cross join. Every result has been matched with every other result, giving us a complete table that puts together our best with every possible customer account, and so on with all of the other ones. Sometimes the cross join is also called a Cartesian product, after Descartes, you know, the mathematician who invented the idea of coordinates and used it with so many things. And you can see this looks vaguely like coordinates. What we really want is what relational database specialists call an inner join. And the inner join works like this. We select the same two columns as before, but this time we explicitly say that we want the customer table to be joined to the cost stack table, and how? The reference number in this one, customer reference number, matches the reference number here, cost stack reference number. So then the computer is going to look for a match every time. B127 is not the same as A123, so that's not right. It compares it to the next, and to the next, and eventually it finds that our best, reference number B127, corresponds with this one, and it puts the data where the two reference numbers correspond. It will do the same comparison again with everything else, giving us a summary table where it has every customer and their account. Of course, the database system has to work quite hard to produce this, trying every combination and keeping only the ones that correspond, that match what we are looking for. So here you can see the real intelligence in our relational database systems. They are fast at giving us data, comparing between two tables, and finding the correct ones in a large number of possible solutions. We got 4 rows of data in one table, 5 in the other. That would be 4 times 5 comparisons to make. But of course, it's a very small database, and in larger ones there may be millions of comparisons to make to get our result. So this is the inner join syntax. At least it's a simple version of it. Practice this one, and there is a little more to be learning about it in other videos.